Hi guys, welcome back to our digital VLSI channel. Hope you are all good. So in this tutorial we will discuss about counters and we will also discuss about the functionality of counters and what are the different types of counters exist in digital electronics. Well, first of all, what is meant by counters? Counters is a sequential circuit. Why it is known as sequential circuit? In sequential circuit, the output depends on inputs as well as previous outputs. Okay, in the same way, the counter is made up of flip-flops, and flip-flops is one of the application of sequential circuit. Okay, it is a digital circuit used to count number of pulses, and also it is used to count the number of times the particular event occurs, and it stores that value. Why? How it stores that value? Because it is made up of flip-flops. Flip-flop, what is meant by flip-flops? Flip-flops is a storage device which stores the bits. And also counters are made up of group of flip-flops with a clock signal applied. Moreover, counters can also be used as frequency dividers, where frequency of given pulse waveform is divided. I will show this in the upcoming tutorial, how counters is used as frequency dividers. For now, just keep this point in your mind. And then types of counters. There are two types of counters. One is asynchronous counter and the other one is synchronous counter. So the name indicates asynchronous means the clock pulses with, suppose for example, let us assume it is a 2-bit counter. If it is a 2-bit counter, there will be 2 flip-flops. If it is a 5-bit counter, there will be 5 flip-flops. So, if it is a n-bit counter, there will be n flip-flops. So, for example, if we consider 2-bit counter, there are 2 flip-flops. The clock pulse, the external clock is applied to only for the first flip-flop. And how second flip-flop get the clock signal means the output of the first flip-flop acts as the clock signal to the second flip-flop, so that the second flip-flop doesn't depend on the external clock. So that's why it is known as asynchronous counter. The clock signal is not given to all the flip-flops. I mean the external clock signal is not given to all the flip-flops at the same time. And what is meant by synchronous counter? In the sense, the external clock is provided to all the flip-flops so that all the flip-flops trigger at the same time and the outputs of the flip-flops are changed with respect to its input. Okay, so this is asynchronous counter. All the flip-flops do not receive the same clock signal. As I mentioned this point before, the flip-flops do not receive the same clock signals. Why I am using here flip-flops? Flip-flops means the counters are made up of flip-flops. I will show the example of asynchronous counter in the next slide. Okay, all the flip-flops do not receive the same clock signal, and the main clock is applied only to the first flip-flop, and then for the rest of the flip-flops, the output of previous flip-flop is taken as clock. This point also I have discussed before, so please read it carefully. The main clock is applied only to the first flip-flop. Okay, and for the rest of flip-flops, how the clock signal is applied means the clock signal is taken from the output of the previous flip-flops. Okay, so that the output of flip-flops do not change affect at the same time. So the the flip-flops change its output with respect to clock. Suppose if we consider a passage of clock, all the flip-flops trigger at passage of clock. Suppose the first flip-flop depends on external clock. So if the external clock goes from low to high, then the flip flop triggers and it changes its output value according to the input. Whereas second flip flop, even though the first flip flop changes from low to high, the second flip flop may or may not change its output with respect to input, because the second flip flop doesn't have the similar clock signal which is applied to the first flip flop. Here the second flip flop has the clock signal, or it depends on the clock signal which was taken from the first flip flop output. When the first flip flop output changes from 0 to 1, then only the second flip flop starts to trigger, and the output of second flip flop changes with respect to input only when the output of first flip flop changes from 0 to 1. Because why 0 to 1? It is low to high transition, and also we assume that flip flop triggers only at passage of clock. I hope you understand this point. So the outputs of all flip flops do not change effect at the same time. So that's why these are very slow when compared to synchronous counters. And also in today's digital world, these asynchronous counters are not using anymore. Okay, examples of asynchronous counters are triple up counter and triple down counter, and we will discuss this in the upcoming tutorials. And also I mentioned that it operates very slowly compared to synchronous counters. So these are asynchronous, this is the example of asynchronous counter. If you see here, this is the external clock, and this is flip flop 2. How many bits, I mean, how many bit counter means it is first flip flop, it is second flip flop, it is third flip flop, it is fourth flip flop. So it is a 4-bit counter. Okay. So for n bit counter it has n flip flops. So for 4-bit counter it has 4 flip flops. Okay. And if you observe for flip flop 2, the clock is, and also if you observe here, this is posage clock, whereas this is negative clock. This triggers at negative edge. Okay. This also triggers at negative edge. Means the output should change from 1 to 0, high to low. Okay. Then only this flip flop triggers and the output changes with respect to input. And then this is also negative edge flip flop. Whenever the previous, that means the third flip flop output changes from 1 to 0, then only the fourth flip flop output depends according to the input. Here, however, input is VDD, that means 1 and 1. So in JK flip flop, if J1 and K1, then output toggles. Okay. In all other times, the flip-flops holds its previous output value or holds the same value. Okay, so this is the best example which describes about asynchronous counter. Now, this is synchronous counter. As I told, synchronous counter in the sense the clock input is applied to all individual flip-flops and they all trigger at the same time. So that's what it is written here. Synchronous counters are so called because the clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. Due to this common clock pulse, all output states switch or change simultaneously. All output states trigger simultaneously. Simultaneously in the sense at the same time. And also, synchronous counters are sometimes called parallel counters because clock is fed in parallel to all flip-flops. So that's why they are called parallel counters. And also, the count sequence is controlled by logic gates. We will discuss this in the next tutorial where we will discuss about synchronous counter in detailed manner. Okay, overall faster operation. Here the faster operation may be achieved because there is no delay. All trigger at the same time. Okay. And this is the example of synchronous counter. Here if you observe the clock signal, the external clock is applied to all flip-flops. Okay. So how it is maintained is through logic gates. We will discuss this later. So that's what I meant to say about counters and the brief description about the types of counters, and also the examples of synchronous counter are ring counter and Johnson counter, and also up counter and down counter. We can made it by using synchronous counter. We will discuss it later. The main example of asynchronous counter is ripple up counter and ripple down counter. So that's it guys. If you like this tutorial, please like, share and subscribe to our digital VLSI channel. Thank you. Bye.